Hello, welcome to the notes on the angle bisector theorem. So I'm going to read the theorem here for you. If a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides. So let's start with a diagram. Let's start with a triangle, and up here at angle A, I'm going to sketch in an angle bisector. So what we know about the angle bisector is it divides that angle into two congruent angles. But from there, we're going to look at the sets of sides. If we have a side here called A side here called C, meaning from the end of the angle bisector to that vertex. We have a side B to the right, and this other side created by the intersection of the angle bisector. Those four parts are proportional. So we're going to say A is to C, they're shared on the same side, as B would correspond to D. Okay. And if we looked at a couple measures, let's say that A was a measure of 18, C was a measure of 12, B is 24, and we are asked to find length of D here. So let's make that a question mark. Okay. What we can do is set up a proportion. So we would say 18 is to 12 as 24 corresponds to D. And our cross products would give you 18D equals 12 times 24 is 288. And divide by 18. D would be a measure of 16 here. So that's looking at the theorem. Now to apply that theorem on a few questions, I'm going to do 1 and 2 with you, and I'm going to ask that you do 3 and 4 as part of your assignment to email back to me or to put up on your Google Classrooms. So looking at number 1, SQ is an angle bisector to angle PSR. So angle S here is what's bisected. And find the value of X. So from each side to the corresponding pieces, we can set up a proportion. I'm going to write 8 compares to X as 5 compares to 6, so that the 8 and 5 are both the parts of the side that is intersected by the bisector. Here, our cross product will give you 5x equals 48, and x equals 9.6 as an answer. Number 2 is a little bit different. And again, number 2 is going to be similar to number 4 right below it, if you need a model as we go. Given triangle ABC below, and I believe something's cut off here, and angle B is bisected. So again, we have that angle bisector, and their markings there gave us that those two parts were equal. AC is 10, so we know this whole measure across here is 10. Find the value of X. Now, if we knew X for this measure, the other piece, this AD, is whatever 10, the whole thing, subtract X is. So we're going to represent AD with the expression 10 subtract X. Because again, we need these corresponding pieces to go into a proportion. So our proportion is going to be 6 compares to 10 subtract X as 8 compares to X. So again, that 10 minus X came from the whole measure, subtract out X, and we have what's left over, our subtraction postulate. Our cross products, we get 6X equals 8 times 10 minus X. Now, most of you, I would love for you to be rewriting that binomial in parentheses and distributing. Some of us I know can distribute in our heads as we cross multiply, but that's where I find a lot of mistakes in our work these days. So 6X equals 80 minus 8X. To get X alone, I'm going to move these 8X's to the opposite side. We'll have 14x equals 80. Now that doesn't divide nicely. I'm going to write my answer off to the side here. X equals about 5.7128. So it doesn't tell us where to round to. We're just going to go to 4 decimal places. And I'm just going to kind of round to the 10th place here for a final answer. So X would be